Welcome to session 22. And now we have Jonathan Gallup, who's a founding partner of Resin Architecture, also from North America. He's our last North American for the day. And Jonathan today is going to be talking about delivering an integrated team for greater project success. Now, from my perspective, I think similar to templates, I think this is also a really important topic to cover from a few different angles. Because of the complexity of several number of people that are involved in a project and how people work slightly differently in certain different regions, or contractually things are differently set up. This presentation, from my mind and seeing Jonathan's approach to how they deliver their projects, is going to be very interesting. So I'll hand you now over to Jonathan to share with you how they're gaining success and how they're leading their whole team to success in working together. So take it away, Jonathan.
Hello, and welcome to this session of ARCHINTENSIVE. I'd first like to thank Nathan and his team for inviting me to present to you. The title of my presentation today is Leading an Integrated Team for Greater Project Success, a glimpse into RESIN'S workflow. So my name is Jonathan Gallup. I was first introduced to Archicad in 2010. I believe I started in version 13, and then shortly thereafter, version 14 was released. I graduated with my master's degree in architecture from the University of Idaho in 2011. And I would say that I've been a virtual builder since 2017. I co-founded Resin Architecture with my business partners Graham Whipple and Greg Croft in 2017. And one of our main taglines is walk inside before you break ground. And I feel that tagline is possible through integrated design and through integrated modeling. I will highlight Resin's integrated design workflow, which allows for greater team collaboration and keeps the architect in the driver's seat from the beginning to the end. This workflow includes live integration with structural, mechanical, electrical, and plumbing engineering consultants, which naturally results in better solutions. This integration not only benefits the design team, but will also highly benefit our client and the construction team as well. Our key learning objectives for today are: 1, learn how to collaborate with the greater OAC team and involve engineering consultants early on to the benefit of the project. 2, learn how to effectively lead your engineering team in a live model for greater collaboration and systems integration. And 3, learn how to continue to be an asset during construction by involving the entire design team from beginning to end. So to start off, Resin Architecture, we are located in southeast Idaho in Idaho Falls. We kind of do work all along the Interstate 15 corridor, or the Intermountain West, and then really wherever our projects take us or wherever our clients take us. So we're happy to follow them kind of throughout the country. I think it's important to start off that we really truly do a lot of our work in our backyard in a pretty rural area, but our backyard's beautiful. It's got Yellowstone National Park, Grand Teton National Park, beautiful rivers and streams and landscaping, wonderful wildflowers, natural landscapes, plenty of opportunity for recreation, downhill skiing, cross-country skiing. And as designers, we have a responsibility to be mindful to all the beauty around us. So at times, we do feel like we still live in the wild, wild west. Who cares what we really build in some of these remote rural jurisdictions anyways? It's up to us to really care enough about our environment and that we're constantly educating ourselves, our clients, along each step of the way. So, the first glimpse into Resin's workflow, I'm going to talk to you about innovative opportunities, advanced tools, and integrated design. Some of these opportunities have occurred or happened to us because we are working in some pretty remote or rural areas. These are some images of a project in a rural western Wyoming town. Um, we were contacted by this particular contractor and client. Once the state of Wyoming got word of their project, they shut them down because they never applied for plan review or for permits. Um, and there were some complexities in egress and the code in the back stairwell. So we were called and retained to help on this project. It was, as you can see, already starting to be drywalled in. So this is not ideal. We typically do not take on projects like this, but they were in dire need of our expertise and in our solutions that we were going to be offering them. So they retained us, and the first thing we did was laser scan their facility just to capture existing conditions. We're able to import that laser scan point cloud into our model. And from here, we're able to model the components, the critical components around the egress path, the exit stair, and start to show the contractor and the client graphically what was needing to happen, what was needing to occur to solve the issue that they had run into that was shutting their project down. So we had to dissect the project and show them lots of 3D visualizations to communicate to both client and the builder. This gave the state of Wyoming, the jurisdiction, confidence in us and our design team and in the solutions that we're proposing to kind of take and route this fire envelope around the egress stair and to show what needed to happen to be compliant. So that was one example of some innovative opportunities that have come our way. This next one, we asked the question, who speaks our same language? We've got with Archicad in our hands, it's a super powerful tool. We have previously imported pre-engineered metal buildings into our models via IFC translator, and that has allowed for great collaboration. But in this case, in this instance, this beautiful guardrail and a historic project, we had to ask ourselves, who in the industry speaks our same language? If we're to export this design via IFC, how can it benefit the project? How can it benefit the contractor? How can the subcontractor who's going to actually manufacture these panels utilize our design and not recreate things? So we're able to save the owner money by utilizing our files and exporting our files, our design out to IFC format, which was a format that the subcontractors could pull in and utilize. So the lower panels, they were able to save a ton of time and labor just by utilizing water jetting. And they didn't even have to do much file prep because we were able to export via IFC and they could import. So just the awareness of thinking outside the box and thinking about how the subs work and how manufacturers can fabricate our designs straight out of our Archicad model, really, through IFC Translate. So those are just a couple examples of how Archicad and thinking outside the box has led us to some innovative opportunities. Next, I want to discuss some of the advanced tools that we utilize in our daily workflow. So first, we strive to utilize our drone for many purposes. Um, we've used our drone to capture existing conditions on an existing site, such as topography, plant life, um, and next, in this example, we use it in our field observation visits to capture construction progress. So after completing a site visit, we took that drone imagery as an overlay straight into our ArchiCAD model, and we're able to point out a few areas of concern. Um, there were some footings that seemed slightly off. There was also some stubbed up plumbing that seemed slightly off. And so we just highlighted these areas, pointed them out to the contractor and to our client, and just said, hey, please go verify a couple of these areas. Feels like after our site visit, there's a few spots that may be off that it'd be good for you to verify and fix if needed. So, here's a few things that could have happened. The contractor could have just been pressing along, pressing forward, but then it would have resulted in a lot of concrete cutting and removal, the reworking of plumbing, and a whole bunch of patching of the concrete. But because of our use of drone technology, and here's what actually happened on this project. They went back and verified things. They said, oh, yep, you're correct. Nice catch. They were able to correct things before placing the concrete pad or slab, which is huge. This averted significant delays and no additional cost. So that was a huge success of utilizing drone technology in our office. And it is made it so that's pretty much standard in our office moving forward. Next, I want to talk to you about a few of these manual measuring tools. So I remember right out of college, we would go as-built some spaces for some remodels, and inevitably to get back to the office to start drafting it up, and it feels like we were always missing a few crucial dimensions. Um, so one thing that we've started utilizing in our office for remodel projects or tenant improvement projects, or any portion of a project that we need to capture any complexities, we utilize laser scanning. So LiDAR and laser scanning. So here's some tools that are really beneficial. Um, what would have taken us perhaps days to go and measure a space and then to model space up now takes only hours. There are some complexities through laser scanning. The point clouds we bring in do capture everything that the naked eye would see, and so sometimes you really got to sort through the mess. This is where we have to be critical about the information that we're really needing to capture, um, so that we only bring in the important or the relevant information into our project. We can fairly easily start to do our new tenant improvement by modeling in the existing from the existing point cloud, all the existing structure, columns, beams, bearing walls, all the existing mechanical, the supply, the return, grills, diffusers, all the portions that are visible first, and then all the existing electrical conduits, panels, switchgear, meters. And as we do that, then we can start to use renovation filters in ArchiCAD to show what's going to be demoed out, to show what's new, and to show what's kind of existing to remain. So again, this is just another example of larger kind of remodel spaces. What would have taken weeks to accurately create as-built plans and base models now only takes days just through the utilization of point clouds. So here's a list of our kind of resins non-negotiables. Accuracy. Again and again and again, we've got to be more and more accurate and to have an accurate base model to start from. Relevant information. We need to be showing what is truly relevant, what is important. And as we're working, we need to be asking ourselves, how relevant is this and to what level? 3, anytime it's applicable, which is typically for additions, remodels, tenant improvements, laser scanning is just non-negotiable. That is proven too valuable of a tool for us to start from. There's so much information from those laser scans that is critical to us that it's just not worth it for us to do it without one. Plus, they save a lot of time and make it so things are just more accurate. Fourth, virtual walkthroughs with our clients. We want our clients to go through these virtual spaces before construction begins. And lastly, integrated base information, meaning we want our base models to be fully integrated as much as possible. Not only architectural plans and modeling, but structural, mechanical, electrical, and plumbing. This is a project during construction. It was important enough for the client that they retained us to do a laser scan during construction, so before drywall occurred. And this has many benefits, but mainly just trying to capture where all the plumbing, venting, supplies, routing, all the HVAC, supply return exhaust routing, just so they could have a record point cloud for years in the future, should they make any changes or remodels down the road. So that was something that this technology has allowed us to do during construction, just for future benefit. As technology has advanced, we now have LiDAR capability on our smartphones, our tablets. So it's just becoming more and more accessible, more and more available, and more common. And so that's super beneficial because it's just easier and easier for architects to now to implement and integrate this into your everyday workflow. Okay, so we've discussed a couple innovative opportunities, a couple advanced tools such as drone and laser scanning. Now we're going to dive deeper really into integrated design. One, how to collaborate with the greater OAC team and involve engineering consultants early on to the benefit of the project. 2, learn how to effectively lead your engineering team in a live model for greater collaboration and systems integration. And 3, learn how to continue to be an asset during construction by involving the entire design team from beginning to end. So here's some questions that we must ask ourselves. Is integrated design achievable? Well, we say yes, it is. We say absolutely yes. What are the challenges? There are many challenges. We'll kind of hit on some of the challenges that we've had here shortly. 3, is it worth it? Again, we believe it's absolutely worth it. The more integrated our designs are with all disciplines involved, the better the results, the better the solutions, and we truly believe that. For what level of integrated design is possible? Well, I know we can continually push ourselves for a greater level of integration and refinement of our own workflow, um, and it's continually getting better and better as we continue to push forward and continue to train and educate. In design, there are many things that can be integrated, and there are many disciplines that can be integrated. So it's our goal to accurately model so our consultants can then accurately place their systems so that we achieve an integrated design that is better throughout and more fully integrated slash developed together as a team. So we like to pull in every possible discipline and tightly coordinate to the benefit of our client and the project. So we prefer to be working together in one live model rather than in our own silos. So each of these different lines from our logo may represent another discipline or another consultant that's coming together for deeper, greater understanding and deeper collaboration for better solutions. Um, Here are some of the internal challenges as we have strived for a more fully integrated design team across many disciplines. Accuracy is valuable. Familiarity with construction techniques and sequencing can be a challenge. We do have pretty young staff, and even our external consultants, tend to have a lot of support staff. There's training and patience. So our own internal team, but also our external consultants, we're constantly training and training and training. Then we got to be patient and then train again. Continuing education, developing our standing by our standards and the continuation of our standards, and then more training and more patience. We host a lot of Archicad user groups with our structural, mechanical, electrical, and plumbing teams, and this allows us to troubleshoot workflows together that really end up kind of strengthening each other. Um, we know the software really well and the tools really well, and we feel like we're constantly training up our consulting engineers to know the tools as well. But it's a team effort for that, where we're learning together. And then here are some of the external challenges that we've come across that are really not in our control. So, not every consultant that we use or have is ready. There's a lot more training and a lot more patience that occurs along the way. Um, Project success, though, leads to future buy-in. So if we can have a great success as a team, then they're more likely to buy in on future projects, which is really good. But then our external consultants also have their own internal challenges, things that we necessarily can't control. Okay, so now I wanted to show, we found that as we build a more comprehensive team in the same ArchiCAD model, that it's helpful to start to have a greater understanding of the level of detail or level of development of the model. So LOD 100 is really conceptual or symbolic or generic representation, and that's where we start out kind of after programming, where we're developing concepts and conceptual models. And then a LOD 200, we're getting the approximate geometries in place, the approximate size, quantity, shape, location of items and elements. And so in our models, this is really at a moving into an SD level and to a DD level. And then LOD 300 is more precise geometries, but more specific systems and accurate in size, quantity, shape, location, and orientation. This is definitely into the DD phase where our engineering consultants are actually placing all their systems into our model. And so things are just getting more and more accurate, more and more precise. And then LOD 400 is really fabrication or accurate detailing, installation information, just way more detail. It's completely ready for construction documents and ready. And then an LOD 500 would be more so through construction and through getting submittals. We get a lot of submittals from the contractors, and so we verify that our model is then matching the submittals, and so that it's basically field verified as well at that point. Um, okay, so conceptual and schematic design. This is diving into really our workflow and kind of these phases of how resin works in Archicad in an integrated model. So we have early conversations with our structural engineer. We own all the data in our model. We have our own structural layers. But we're giving our structural engineer viewer rights and read-only rights into our live shared model because it's important for us to involve them early on to really set up a good framework and a good base. So we'll have a consultant kickoff meeting at this time with structural, mechanical, electrical, plumbing, and a lot of times civil. But near the end of SD, our structural engineer validates the sizing of columns, beams, floor joists, roof trusses, etc. So like everything that we've planned in and modeled in, we have our structural engineer kind of validate that we got things, fairly accurate, fairly close at this point in time. And really starts off, this is just a example of a medical office building we're working on, but it's very, very conceptual at first, just simple zones. We're really just looking at basic kind of space planning and looking at structural grids. Then we're starting to add in some furniture layouts, equipment layouts, and this is just to validate our space planning is accurate and also to validate and really help our clients kind of understand the flow and what they're anticipating here. So as we move from SD to DD, this is now where our structural engineer really starts to take ownership of items in our model. So they start to take those columns, those beams from our structural layers. They reassociate them. They then move them to their own layers within our model. And structural then focuses on beams, columns, truss steps, truss versus beam, if it's solid versus triangulated. They're working to define like a framework at this point where we can appropriately route and find mechanical, electrical, plumbing pathways, where we need to provision for a hole through a solid wall or a beam. And so we're starting to get structurals refining a lot in the model, and then we're getting MEP starting to route things as well. So here's an image, kind of right as we left the concept SD. Structural usually is the first one we get in and going first because we want all the major structural components in first. And then shortly thereafter, we feel it's best to get all the major mechanical items in, all the supply and returns, ductwork, and then major trunk lines. We're not necessarily worried about exact connections and bends, but really just the major trunk lines. And so the model now is starting to become more and more detailed. That LOD that we talked about, it's starting to be refined as we're working through with our consulting engineers. And really at this point, we invite MEP consultants to their mapping out the zones, the areas, the volumes, and they're locating their major equipment, and we're trying to protect the clearances within the model for them. It's all about the right people, integrated project visualization. So having the right team and the right people allows our models to be more developed and more fine-tuned, which leads to greater success. So we can start to really visualize all the building systems. And this is just a section cut kind of sample that's really starting to show supply and return duct lines, structural, plumbing, even seeing some shear walls in red. And so these are some things that we've set up to where there's some really visual clash detection starting to happen live in our model. Um, Kind of a bulleted list of what's happening here. So MEP is placing their major HVAC and major drain lines. Electrical is really doing any significant raceway that's like over 4 inches in diameter. We don't get really too hung up on any small conduits, things like that, but major switch gear, electrical meter, electrical panels, like getting all that in for sure. Um, and in this image, we can start to really create a standard for this visualization, um, where we can show shear walls or bearing walls and shear walls in red, um, or firewalls, as well, so that as we see any penetrations, we know they need to be protected or fire rated. But by changing some of the architectural skins and these roof assemblies or these wall assemblies and floor assemblies to wireframe, we can run through and do visual clash detection and visual coordination kind of in and out throughout the building through all the systems. So super helpful to be able to peel away the layers or peel away the finishes to start to see how as a team we're all working together in one live model, to really fully coordinate the project. And so that really brings us to the construction documents, which at this point in time are coordination's complete. Um, and so it's really just about extracting the data, kind of doing the documentation, doing all the scheduling, and then any finalized detailing. So this graphic is really what we like to see live in our one Archicad model. Resin as the center of it all, or resin controls the base model. We have resin interiors that is live in our model. Resin interiors also works live in other architects' models. There are some other architects that hire our interior designer to model live right in their models and do interior design for them. And so that's another key component. But then we're pulling in these different disciplines, structural, mechanical, electrical, and plumbing. And as we pull them in and as we model accurately, we have integrated design and integrated model, which benefits the project greatly. So Resin's expanded integration, base integrations all within the same model. All members work actively in the model. Um, IFC and OpenBIM do offer a world of solutions, and we support and we encourage IFC outside of the core model. Um, but accurate modeling in the base model is what allows for accuracy in all disciplines. And so it really starts with us, really at the heart of it all, which then allows our consultants to be accurate as well. We've seen a huge success of this model of integrated design. There's increased efficiencies, there's shared geometry for accuracy, there's a consolidated information within the model, comprehensive visualization, there's improved clash and collision detection and resolution, and then there's live collaboration happening kind of throughout the whole design process. Right here are some screenshots of a few random current projects that we're hosting on our server. You can see we've got internal team members and external consultant team members in our models. And so we're actively using Teamworks, we're utilizing Teamworks and fostering that integrated communication in Teamworks as well. Um, we can't always rely upon the communication right in Teamworks itself because our consultants are not always working in the model the exact same time we are kind of throughout the day. They've got their own schedule, their own deadlines, and they manage a lot more projects, and other projects. And so we still have to kind of revert back to picking up the phone and calling them to coordinate, or emailing them and scheduling coordination sessions with them. But what I want to pull from this is that we truly are having all these disciplines in our models to really pull together all the components and systems of a building into one integrated live model, which works really well for us. Because of a coordinated model, there are less surprises during construction, and we like our clients to see everything for them to experience walking through the virtual reality VR headset and seeing all the different systems into one integrated model. Hence, why our tagline is "Walk inside before you break ground." This slide here I wanted to throw in just to kind of show our basic tool belt. We don't have a lot of tools that we utilize. We do try to keep it pretty streamlined or pretty straightforward. Really, Archicad is at the heart of it all. We do utilize a ton of BIMX by showing our clients BIMX models. It really puts it into the palm of their hands and their smartphones and their tablets, which is powerful. We use Matterport for our laser scanning, which is a pretty basic LiDAR, nothing too fancy, but it's proven extremely beneficial. And then drone deploy and Epic Games Twinmotion rendering. So I discussed some innovative opportunities, some of the advanced tools that we're using, and then a lot of the ways that we have structural, mechanical, electrical, and plumbing live in our same integrated design model. Now that I've highlighted our integrated design workflow, what are you going to implement? Push the industry, challenge yourself. Um, Any questions? I think we're going to open it up now to questions. Thank you, and I really appreciate your time and the glimpse into our integrated workflow.